Hello, and welcome to Math 131, Week 3, Part 2. So last week, earlier in this week, we covered graphing, and right now we will cover the section on aggregating. Graphing was a little bit longer than the 20-minute videos I'm shooting for, so I'm aiming to make aggregating less than 20 minutes so that my average will remain right about 20 minutes. Let's get to it. So aggregating is going to be a lot of the same tricks that happened behind the scenes in the plotting videos. Let's scroll up just to reference it a little bit. If you recall, we took one categorical variable like var, and for each level of the categorical variable var, we summarized the data within that level. So here we are calculating box plots and a violin plot within each level of var. So insectivores got their own summary statistics, omnivores got their own summary statistics, herbivores got their own summary statistics. Okay, we get the idea, and carnivores did as well. We're now going to be doing that by hand, well, by code, ourselves, instead of letting ggplots functions do it for us. In order to do that, we'll start by grouping a data frame. So let's get our Google Colab notebook up and running. I've already done this. If you have not, now's a good time to pause the video and do so yourself. I've installed the libraries, updated the libraries, and loaded the dataset msleep that we'll continue using. Now I'm going to create a new variable. I'm going to name it ODF for not really any good reason here. I'm going to start with the msleep dataset, and I'm going to group the msleep dataset by the categorical variable var. I'm going to put as index equals false, and I'll explain that why I do that in a little bit. If you run that code, you successfully get a new variable named ODF. You get a warning message, which we can completely ignore for now, and then it prints ODF. Unfortunately, all it prints for you is that you now have a new type that is a data frame grouped by, and that is an official Python type. It is a data frame that has been grouped. Effectively, grouping just sets stuff up for you to do things later. So I'm going to help you visualize this group data frame, even though it won't let you immediately visualize the group data frame yourself. So I'm going to help you try to visualize this group data frame using a Python for loop, which should come in most standard Python introductions. Unfortunately, we don't cover them in this class, partly for the sake of time, partly for the sake of most data science stuff can get away without them. But here is some fairly complicated code that in office hours I would happily help any of you through. We're going to create this for loop, which is effectively going to go through each new group in ODF, the variable we just created. It's going to print the group name, and then it's going to print just the top 5 rows of only these columns. And hopefully with that, we can get a better understanding of the function group by. So you see what's going on here is, here's the first group name, carne, for carnivores, and you can see under the column var, it's only carnivores. We have grouped all carnivores together. So here's the genus of all carnivores. Here's the conservation status of the carnivores. Really, it's just the first 5 rows. And then here's the sleep total of the first 5 rows of carnivore. But all the rest of the animals in this first printed grouped data frame are indeed carnivores. We have lumped all the carnivores together, we've lumped all the herbivores together, we've lumped all the insectivores together, and for each level of var, carnivore, herbivore, insectivore, omnivore, we have the appropriately matching data for that observation within the level of var, omnivore. So this is a reasonable way to visualize what a grouped data frame is doing, even though it doesn't let you visualize that by yourself. Okay, So grouping is the first step towards meaningful summary statistics within each group. So what we're going to do is take that grouped data frame, ODF, and next we will aggregate all of the variables within sleep total for each level of VOR. So we're going to calculate some summary statistics on the variable sleep total. Some obvious ones are like means, or maybe we're going to count the number of omnivores within this data set. And I'll also show you that you can calculate standard deviations. And it's all going to happen on the column sleep total. So here's some code that I'm just going to type out, and then I will help you understand what it does. So within the function aggregate, that applies specifically to our grouped data frame that we created above, I'm going to create a new column named mean. That choice is totally up to me, but obviously better and more meaningful variable names is for everyone's benefit. So I'm going to name it mean, and on the column sleep total, within each level of this group data frame, so for the sleep totals of omnivores and for the sleep totals of insectivores, we will calculate the mean using NumPy's function np.mean. And so here is all the code you need to create a new column in your group data frame where you choose the name of the column, you specify what variable you want to do calculations on, and you specify what function we want to use to do the calculations. And this alone will calculate the mean of sleep total within each level of VOR, because that's already been encoded in this grouped data frame. You can calculate effectively as many functions as you want. So we could calculate the sleep total using NumPy's built-in function std and name it into a variable sd. We could also calculate counts if you wanted to on the variable sleep total grouped within each level of VOR, and we'll just use np.size. We'll save this into a new variable. And we will find my typo. There it is. Sleep total does not exist. Okay, and here's our output. For each level of VOR, we have a mean of just the carnivores' sleep total. For each level of VOR, we've got a standard deviation of, let's say, herbivores' sleep total. For each level of VOR, we've got a count of how many variables showed up in the column sleep total that were insectivores. And so here's a fairly good summary output of our grouped and aggregated summary statistics. This indeed is a new data frame that we've got now. The column VOR was included in this new data frame specifically because we specified as index equals false. Anytime you want to use the variable that you have grouped on later in your data frames, you need to specify as index equals false, and that will put the column you're grouping by, that will give it its own column. If you don't put as index equals false, it, in my opinion, makes things just a little bit more challenging for you. So that's why I'm leading by example. Anytime you create a group data frame, specify as index equals false. This is indeed just a basic data frame like any other we've dealt with in this class. So you could do things like, here's just an example, create a new column named SE for standard error. This is some relatively statistics stuff going on, but we'll just give some more examples. So you could calculate standard errors and insert them into the data frame GDF. And here it is. Here's that new column we just calculated by taking the standard deviation and dividing by the square root of counts. Okay. The last thing I'm going to show you is that you can take this data frame GDF and you can use it to make ggplot plots. So I'm still just trying to emphasize the point that we kind of already did these grouping and aggregating calculations above with plot9's function ggplot, but now we're kind of doing it by hand such that you can get out the exact means of each level of VOR yourself. And if you wanted to, you could then put those means into a plot where we have on the x-axis each level of VOR, and on the y-axis the means we calculated ourselves. That's great. In next week's video, we're going to extend on this combining, grouping, and aggregating calculations and making a little bit more sophisticated plots than what you get out by default from plot9.